morning, everybody. First of all, quick apology. Yesterday, I was unable to give you a forecast video. I had to be up very early in the morning, and that was because I had an extremely just incredible privilege to go visit one of the mines in Saskatchewan, a potash mine. And if you don't mind, I'd like to share with you a quick story about it and kind of relate it back to some of the things I used to teach at university, and then we'll get into the forecast. Other quick announcement, tomorrow morning there won't be a video. I don't get home. I have to red-eye home tonight, and I won't get home until middle of the day tomorrow. And as a result, I'm just going to push off till Friday so I can get kind of recover and get some sleep. But this thing I've been doing the last 24 hours has been incredible. I was invited to go visit a potash mine, and I knew that I'd be going about 1 kilometer below the Earth's surface to see how this mining operation works. So in preparation for that, just because I am a giant nerd, I decided to do some quick math to understand what the pressure was going to be like when I got down there. So you've been staring at this same image. This is just this is the hotel I'm at here in Saskatoon, and called Alt Hotel. And I just decided to pull out an equation I used to teach my students at university. And it's a kind of an equation of first importance. It's kind of a fundamental equation that we teach kids early in atmospheric science called the Hypsometric equation. And it's simply this. There's a relationship between the pressure between any two layers in the atmosphere, so P1 and P2, and their thickness. So that's a change in altitude. And it's related to a constant, which is this sequence of, or this series of variables here. Now, what are they? RD, that is 287, which is the amount of energy required to change 1 kilogram of dry air by 1 Kelvin. And since one change, a 1 degree Celsius change is equal to a 1 Kelvin change, you can think of this as just how much energy does it take to change the temperature 1 degree C. Okay, TV, that's a reference temperature. It represents a virtual temperature, so it includes water vapor. I set it at 30 degrees C because that was the temperature I measured at the bottom of this mine. And how far down did we go? We went down 1 kilometer. So my delta Z is 1,000 meters to keep this all in SI units. Now what we get here is that there is this natural log, so there's this nonlinear relationship between pressure. In fact, we know that it changes exponentially with altitude. So what I wanted to know is when we got down to the bottom of the mine, what would the pressure be? So I'll just show you how to solve this equation. First of all, I substituted all of the constants for the value of H, moved it around, took the, got rid of the natural log, and then plugged in my numbers. My handwriting's terrible. I apologize for that, but this is just what happens after 25 years of doing math all the time. Anyways, when you plug all the values in, all right, what you end up getting is an estimate that 1 kilometer down, I would experience a pressure of 1,131.7 millibars. Now, what does that mean to kind of the average person? That's a pretty sizable increase in pressure. Just general reference, average sea level pressure across the planet is about 1,013 millibars. So what happened is I got on an elevator, and that elevator went down very, very quickly. And I decided to use an app on my phone because our phones, most modern phones, have the ability to measure barometric pressure through a little piezo-resistant, there's a little piece of electronics on your phone that lets you do this. And I kept grabbing off the values as I went down. Now, just to let you know, this happened over about 6 minutes. The elevator speed was about 25 miles an hour. Sorry, I'm switching back and forth between SI units and imperial units here, but we were moving fast. A normal elevator is about 3 to 4 miles an hour. And I just did this. When I got into the elevator, the pressure at the site, this is the Allen Mine in very near Saskatoon and Saskatchewan, 1,011 millibars, so very close to average standard sea level pressure. What was interesting was after a few moments of just going down, meaning the pressure was going to increase, I surpassed the record highest sea level pressure ever observed in my home state of Illinois, which happened on February 16, 1989. I was just 9 years old. Actually, I was only 8 years old when that happened. I was about to turn 9. And then a few moments later, we broke the world record highest sea level pressure. Now remember, we're not at sea level, we're going down. That was set in Mongolia in 2001 at 1,084. My ears were just popping the entire way. And after this relatively short 6-minute elevator ride, going 25 miles an hour, we were a full kilometer below the surface. And the pressure down there was, you can see the value. It's 1,139 millibars, which is interesting because that's pretty darn close to what I calculated it to be. Now, they just told me that we were roughly about a kilometer below the surface. And so, the calculation kind of works out. So this is the exponential increase in pressure with height. And you can actually see how it's nonlinear, okay? And this is interesting. Now, I'm graphing it out against time, but you can see because the elevator speed was relatively constant, the nonlinearity in that. It was an amazing thing. And by the way, how fast is 25 miles an hour? So we're basically crossing a football field in every, what would it be, every 15 seconds? That's about how quickly this elevator was moving down. So this was wild. I asked everybody if they wouldn't mind jumping when we took off. I thought it'd be kind of fun, but no one was up for it. I think there's a little bit of nerves going down at the bottom of this mine. Okay. All of that is just to share with you that when I got down there, it was an absolutely amazing experience. And what's interesting is that pressure, because they have giant air handlers, keeping fresh air down there, your lungs are just saturated with oxygen. So walking uphill and moving about down there, it's actually easier than at lower pressure. And just to complete the story, last week, this is just one of the amazing things my job lets me do. I got to go to the Sequoia National Park in California, where I went to see General Sherman, of course, the absolutely massive tree. And that was at 6,500 feet, where the pressure was substantially lower, and I was huffing and puffing walking up and down those hills. Okay, so I'm showing you all this because let's come back to kind of the big idea here. Got down to the bottom of the mine, and this is how it looked. Now, what's interesting about the way we mine potash is that the structure doesn't have to be, I learned all this yesterday, it doesn't have to be reinforced. So when they mine this out, and again, the potash, what we need out of it is the potassium. As they cut through, you'll notice there's no scaffolding. This particular spot was cut, I believe they told me about 5 years ago. And once you get out of the lighted areas, all you've got is what you have with your equipment. And so it was amazing. We got into some parts of the mine where it was completely dark. Now, all of this, okay, is the potash that is needed as a massive and important part of our fertilizer industry. But what I discovered when I got there was that the potash deposits here, again, potassium, this was from an ancient seabed. And how ancient it was, 380 million years ago. And I was talking to one of our guides, she's a geologist, her name is Zoe, and she said that this particular seabed, if you use a plate tectonics model, was actually in Peru. So over 380 million years moved from Peru to central Canada. And I got down there and took some videos. Now this was, I don't know, for me this was just incredible. But the first video I want to show you is when we got to walk up to where they had just been mining. So what you're seeing there is how the equipment is cutting away and taking the potash out. And he's pointing out to us those interesting colors which represent different layers. Some are clay, some are salt. And he explained to us how this is so structurally important to the mining operations, which, to be honest with you, the most amazing thing I saw out of this was just the incredible amount of safety that goes into doing this. And, incredible things. Now, if you look in the background right there, you see the two large kind of concentric circles. That is where we just mined fresh potash. So I'm the first person to see that, like ever. And that is the first time that's been exposed in 380 million years. And it's very quickly put onto a conveyor belt, which you're going to see here, and taken back. Now, how far? We were, I think we were about 13 kilometers from where the elevator was. So we drove for about 40 minutes to get to this particular spot. And so they'll take all of this out. And this is what's amazing. In 6 hours' time, they will have already extracted the potash, turned it into pellets or whatever else they needed to do in an incredibly environmentally friendly way. I was impressed by that, and it's ready to be put on a train and shipped around the world. And what we're after is over here. So if you just watch this is, you're going to see my hand. I've picked up a piece. I'm taking that home with me. Hopefully I can get that through customs, and there it is. And that is the first time that's seen daylight in 380 million years, and it's just an absolutely amazing experience. Now I'm going to tell you something else that was crazy about being down here. The entire time, because of the way modern mining works, I had a Wi-Fi signal, and I was getting texts and emails and pictures from home, because at home there was this. I knew there was going to be strong winds. We talked about it on Monday. And so now to get back into the weather, I just want to show you, this was a fire near Champaign, Illinois, a field fire. And as soon as I got back to the surface, I began to pull up images because I wanted to know if I could see this on satellite. So this is the sun rising early this morning here, but I'm going to take you back to yesterday. And we knew that as this system, right, we've been talking about this one for a long time, was going to come out, that there would be some incredibly strong winds out ahead of it. I couldn't see the fire, and the reason for that is because we had some cloud cover over the top of this. But the sheer number of people sending me messages all day long about how rough the conditions were with these incredibly strong winds, I knew that it was going to be a tough go of it. But I was here, way up here at that mine. So this is our story for right now. We've got a couple of these coming. This is a deep low. This is about the time of year we start to see these lows take on their typical synoptic shapes, big comma heads, and the ability to produce snow and severe weather and heavy rain and bring in a lot of cold air on the backside. We're about to have about 6 months of seeing these things repeatedly go across. And by the time we get into later on today, you're going to see this one develop a very sharp front right in through this area where it's going to be very windy and very warm out ahead of it, severe weather along the front, and a very abrupt change in temperature behind it. But the setup here ahead of our next one, which you can see here, is just, it's classic. There's high pressure over the southeast and mid-Atlantic, and the flow is just coming around, opening up the Gulf. There's your boundary. That's going to force air to rise rapidly, where it will decompress as it goes up in the atmosphere, allowing for expansion, cooling, condensation clouds. And some of this, as it comes through, is going to be producing some severe weather, which we're going to talk about here in a few minutes. Now, if you would have shown me this in May, I think we would have been talking about a high-end severe weather event here. But it is late October, and the atmospheric stability is very different now than it is in May. It's much more stable. While there will be severe weather today, it will be strongly forced along this boundary rather than extremely widespread along the boundary, out ahead of the boundary, along the dry line feature, which is here, which is what would happen if we were in the heart of the severe weather season. Unfortunately, there will be some strong winds with this system and the one that follows. This just quick animation here. Let me refresh this. Hopefully it'll refresh fast enough. My internet connection is just fast enough here in the hotel. But these are the winds we are expecting from the first system. So that'll get you through Friday. These are wind gusts. And then you're going to see the second system that comes into the Intermountain West. Again, the Mountain Valley wind system here is going to be absolutely cranked up. And that one's going to come through, again, the 3rd, 4th, 5th. And if we just let this go out 10 days, about the only place that is going to be staying away from the stronger winds is going to be the southeast and here across parts of the Canadian prairie, maybe a little bit into the northwest as well. So we got more wind to deal with. Next, our all hazards weather map. We have winter weather advisories, winter storm warnings that are out for our mountain ranges in the west. These are all freeze warnings that have gotten down into the panhandles down here into parts of Arizona and New Mexico. Remember, we've been setting records for heat in Arizona, so this is a pretty big change. All of this is related to wind and red flag warning and the risk of fire. We do have red flag warnings back here in Texas and Oklahoma as well, kind of the headwaters of the Red River Valley of the South. And the temperature contrast this morning is incredible. If you take a look at it, we've got 26 degrees in parts of Montana, but in the warm sector, we've got 70s already early, 5:40 a.m. Central Time. So this is what's going to get us set up for a pretty active go of it. And here is the latest I've got for the next 7 days. And so we look first at our drier areas. I think the closer you are to the Rocky Mountains, the drier it's going to be, but in the mountains, a lot of snow. Canadian prairie is relatively dry. The southeast is dry. This is where our high pressure is going to be sitting here and here. The lows enter the northwest, which we'll take a closer look at in a few moments, dig into the Four Corner States and eject. And the one that's ejecting now is going to be adding a lot of rainfall into this area. I'll show you a close-up of that in a few moments, but I want to talk to you about the severe weather setup for today. Let's see if I can get an update here. We have a large area that's under a slight risk, and this part of Kansas getting into Missouri, parts of Nebraska is under an enhanced risk this morning. And so this just tells us kind of how potent this system is going to be able to get this far kind of on our risk scale at this point in late October. To show you the other side of this, we're looking at quite a bit of snow. You can see it coming into the Cascades. The Sierra Nevada are going to pick up in the whole spine of the Rocky Mountains. But there could be the possibility in the backside of this to be getting some snow here in the western and high plains and possibly in the upper Midwest, stretching into parts of Ontario as well. So we'll need to take a closer look at that in a few moments. So here's what we're going to do. I'm going to refresh this and hope that my internet speeds can keep up here. But this is the high-res NAM simulation from 6Z this morning. Let's get it queued up to about the time you're going to be watching it, about 8 a.m. So pressure gradient very tight. That's our strong winds. High pressure over the mid-Atlantic and the Carolinas. Now you'll be also watching another front coming into the northwest, but the first system is here. And as it pulls through, we can see the snow coming out of Wyoming into Colorado. And then it will be tonight that we're going to watch along this boundary the risk for the severe storms to blow up. Now it'll be strongly forced. It'll all be along the frontal boundary here that we're going to be seeing this. But heavy rains for parts of Iowa, getting into southern Minnesota and Wisconsin are possible. And then the back side, as the front pushes forward in the overnight hours through early Thursday, we have to watch out for the risk of snow here. So the high-res NAM is putting down that snow in this area. It's going to carry it through Minnesota into parts of northern Wisconsin as the front pulls through by Thursday evening. So this will be about the time a lot of kids will be trick-or-treating. So I'm going to ruin your day here. If you're going to be trick-or-treating, it'll be quite interesting. You can see that pencil-thin line there. That's our frontal boundary, some storms out ahead of it. Quick temperature change on the backside, and then our next system. So if you're in the Willamette Valley, Central Oregon, some of the mountains here in Idaho, some heavy snows around trick-or-treating time as well. So we watch this pull forward, and you'll notice that it does not extend the heavy rain into this part of the Northeast, getting back toward the Ohio Valley, which is a very dry region right now. I'll show you that again in a few seconds. And the issue here is the trajectory of this low and the presence of the high pressure is just knocking out the ability for that front to carry the moisture any farther. So you're just going to see it kind of not get into that area with as widespread a rain as it's going to be producing in the central U.S. We will watch through the day on Friday the front linger over parts of Tennessee, Kentucky into the Mid-South. But again, our attention is going to go to this next system coming into the Northwest. You can already see it on midday Friday. But on the 2nd, 3rd, 4th, and 5th, our next system is going to come through. But the high-res NAM doesn't go out that far. So to show you that, I'm going to flip over to the artificial intelligence upper-level height pattern forecast, if I can get this to reload. So I apologize that this takes a bit of time here in the hotel. But I think the AIFS has done the best on picking up on the pattern. And I'm going to show it to you, what it's saying now. So here's the trough we're watching. The ridge over the southeast, so there it goes. You see how that trough just kind of was deep and then died? That's the influence of this ridge. It just wiped it out. It's got no support behind it. It's not linked to brutally cold air, so it loses. It lost the battle to the ridge. Now playing it forward, here we are on Friday, that next system I mentioned in the northwest. It digs, and this is the one that's really, I think, even has a bigger potential because it's got that classic setup with the trough on the backside that's broader, the shortwave out ahead of it, and this one's going to send the shortwave quickly through this area. And when are we? This is Monday, getting into Tuesday. So it flings it. Watch this again. Are you seeing this right here? Just watch it get flung right toward Wisconsin, and the reinforcing trough is behind it. Now we're all the way out to next Thursday, and the AIFS is one of the only models that takes that and leaves it lingering as a cutoff low. I'll be watching this, and you can watch it too on agweather.com. All the model runs today to see if the AI continues to do this. Because if it leaves this around here through next week, this is going to be a potent system through the midsection of the country to be watching. And it's going to be one that you're going to see the AI model showing very wet through some of the driest parts of the country. Now, but will we see this get into the Northeast, another extremely dry area? Right now, the model's carrying it straight to the Great Lakes. See that? And we're going to have to watch to see if anything follows it as we approach the middle of the month. But that's the pattern we've got, and you can see it remains active through the middle of the month. There are lots of shortwave troughs moving through this pattern. So let's dig into this. Let's take the next 7 days. Remember, on agweather.com, you can see 5 models right away on the main page. You got the European, artificial intelligence, the GFS, the WPC, and the national blend of models. I'm going to zoom in on the WPC and show you a couple of areas. We're going to start in the west. So this does include the next 2 systems combined. And we notice that while Montana is drier because of these systems coming in and diving, we do have rainfall amounts or total precipitation amounts that are pretty high here. For example, throughout the Willamette Valley, even some places in the Columbia Basin capable of getting 0.3 to maybe a half inch of rainfall. This is going to be some of the first seasonal rains that are going to get into the Central Valley of California as well. And the moisture that's going to get down into Arizona, the Sun Belt down here. This is fairly good moisture for this time of year. From there, let's kind of come over to the central United States. Look at the south central U.S. first. Southeast Kansas. Now, do I buy in that by next Tuesday there'll be 7 inches of rain here? I'm talking to you guys specifically that are from Southeast Kansas that I know watch my videos, and I appreciate the comments you leave. They're valuable to me. I don't know. Is this overdone? Possibly. Is there the chance of it? Yes. I'll show you the probabilities in a second. But holy smokes, that's a lot of rainfall if it comes through. And you say, why? 2 systems, 2 frontal boundaries lined up on the same spot. And that's what we're looking at. Let's go a bit farther to the north of this area and look at the north central U.S. And as you take a look here, getting into Iowa, Missouri, parts of Illinois, the chances of picking up 1 or 2, maybe 3 inches of rainfall is high, and it's much higher back into parts, again, Kansas and Missouri. Now remember, I told you the WPC gives us a product and everything looks very smoothed. And that's part of the way they designed it, just so that you're aware. But understand that when the rain does fall, it's not going to look exactly like this. Let's do one other thing. I'm going to switch this over quickly here to the east, if I could spell that right. And if we look just across the whole of the eastern U.S., you can see the influence of the ridge. And we see a lot of zeros, which means the drought that the east is enduring, especially the northeast, after the hurricanes in the southeast, is going to persist through these next couple of systems. I do want you to be aware that the risk of these severe storms is quite high. So I'm going to zoom in on this kind of north central U.S. view. We're going to look at the high resolution rapid refresh model. And when are we? We're about 10 o'clock this morning, playing through this afternoon. And that's where we could start to see the early convection popping in, parts of Kansas, Nebraska, and Iowa. We could even see it over toward the Mississippi River. But most of this will be forced along the frontal boundary tonight here. But there is risk of some strong storms with this, and they could rotate. There could be hail producers with brief but strong straight line wind gusts. It's got multi severe weather threat here. This is 11 p.m. tonight, Central Time, according to the high resolution rapid refresh model. It starts to come over the Mississippi River between 1 and 2 a.m., lingering all the way back down here through that same time period. The timing of this going overnight across Illinois will determine storm structure. Will it be elevated? Will it be fizzling? That's going to be the difficult thing because 5 a.m. is not a time for storms. But we're going to get this boundary coming through, and should be interesting. I should be landing at O'Hare at about that time. I don't know if I'll make it home, actually. That'll be really interesting. But this could zip through, and then through the middle of the day on Thursday, we'll watch that boundary kind of move over parts of the Ohio Valley with the snow on the backside. This will likely be snow here in northern Wisconsin. I want to show you another way. This is the high-resolution European model, 0-0. Let's refresh it and just see how it shows us the next 10 days. So we've seen in detail through Thursday. This is Thursday afternoon and evening. So that's from 1 o'clock in the afternoon through 7 p.m. where the precipitation is expected to be on Thursday. And we're going to watch this go through. We know that front's going to try to bring some moisture into the northeast, but not get there because of the high-pressure cell. And then we see following it, the next system coming in. And already by Saturday, we're rebuilding the warm sector, rebuilding the moisture here. And we're going to see lots of storms in the southern plains, kind of coming right back over that same part where the expected heavy rain was from the WPC. And we see this next storm system moving through. Again, when is this? This is Saturday, Sunday, Monday, Tuesday. That's several days of rain. That's why the risk is there in this area for possibly several inches of rain. And then that system moves through by next Tuesday into Wednesday, and it's out. Now, that's a pretty active go of it just here in the near term. And I mentioned some snow. Can I show you what the latest snowfall forecast is going to be? Let's get a refresh on this real quick. As we play this forward, most of this is going to be western snow, but you can see, look at Minnesota, UP, look at parts of Wisconsin grabbing some snow. When is this? This is Halloween. And then we watch the next system dive in and really dump the snow throughout the major mountain systems in the west. And so a 10-day snowfall map looks like that from the European high-res model. Let's come back to just total precip and look at probabilities. So this is the chance over the next 10 days of 1 inch. This is the chance of 2 inches. Hopefully we didn't get the new model run in yet. Oh, we did. Just came in. Just started. Let's go back and get you out there. I have no idea what that noise is in the background of my hotel room. That's about 10 days. For some reason, it's not loading anymore. That is, the heck is that? Okay, anyway, I'm sorry, guys. That's the chance at 2 inches, and here's the chance at 4. I mean, that's a lot of precip. And right there's that corridor. So it's not just the WPC. The European Ensemble's got it too. So does the Artificial Intelligence. So does the GFS. They've all got it. Drier side of things. Who's staying under a half inch? Canadian Prairie, Northern Plains, the Southwest. We then see the Southeast and up the East Coast has the best chance. Now, after this, I'm going to tell you, after the next 7 or 8 days, we do have better chances of rainfall in the East. But right now, you look at a whole 10-day time period, and it's just not there. And the problem is that is an area that's been very dry. So I know I focused a lot on the central U.S. over the last several months, but you can't ignore the fact, I mean, we've got record dry. It is the driest October on record in New Jersey and surrounding areas in the Atlantic and the Northeast. We also have the Ohio Valley, the Mississippi Valley, the Missouri Valley, the Red River Valley, the Arkansas, I mean, all of these major river valleys, the Tennessee, just incredibly, incredibly dry. And all of this here in the Four Corners season from one cutoff low, right? Just one that happened, I don't know, 10 or 12 days ago, which we talked a lot about. Soil moisture, this is a map I'm looking to see change over the next 10 days. It's going to be critical to see this change over the next 10 days. Because if you look over the last 30, we now no longer have Helene in the data. And so you can see here that over the, well, some of the remnants of Helene, but nothing else here. That other than Milton and the cutoff low and a couple of systems that clip parts of the Northwest, we've been extremely dry. So what about that week 2 time frame? This is where we start off week 2. It's still a highly amplified pattern. This is from the European Ensemble. And it's just showing us here, I'm sorry, it's not playing for me. I think this is just an internet issue with the hotel, that we've got an active pattern. And that's why we look out there and see that the day 8 through 14 maps all have a similar thing with another low coming through the southern United States, better chances for rain in the southeast in all the models, even better chances up the East Coast. So the pattern is going to remain quite active through the middle of the month. Now, since I mentioned the southeast, you can start to see in the European model some really wet conditions here. That's partly because we've got a tropical system that we need to be keeping an eye on. It hasn't formed yet, but there's the chance of a disturbance developing at 40% over the next 7 days, according to the National Hurricane Center. And then if you look at the 10-day European model forecast, the ensemble average is about 50 to 70% in through this year that we could get some more tropical development. And again, that follows the MJO movement we talked about, just taking the lid off of this area, knowing the waters are still quite warm here. So speaking of warmth, let's get into a temperature discussion. This is the next 7 days of risk of frost across the lower 48, everywhere in gray. And if we look at these high temperatures, let's refresh this and see if we can get the right maps to pop up here. This is what our high temperatures are today. Look at that contrast. No problem finding the front here. This is today, Thursday, already big swings. So prepare for this in this area. Look how cold the West Coast is. This is your Halloween, and it's quite cool here. Then Friday, Saturday. Oh, come on. Apologize. This just tends to happen sometimes. Well, it gave me Sunday. There's Sunday's highs and Monday. Now, what's the warm up? This is the reloading around the next deep low that's in the west here. And this is the 4th. It's going to eject the 4th and 5th and come across the country and give us kind of a repeat of what we're about to see over the next 48 to 60 hours. Temperature-wise, day 5 through 10. This is something that was interesting in the shift in the models. Remember I told you early in the week, like, watch Alaska, it's getting quite warm. That tends to be able to push more colder air farther to the east. Some of the new forecasts take us out to day 10 through 15, and they're saying that southeast ridge is so strong that overcoming it, despite changes in Alaska, seem to be limited. So we're going to have to watch that very carefully as well. Okay, so we started off on a potash mine. I just walked you through 2 pretty sizable events hitting some of the driest areas in the country. And now we got to figure out where this might go beyond that. Now we're at the end of a month, which means we're going to begin some new long-range data very soon. In fact, by Friday, I'll have the new update from the CPC. But what I'm thinking a lot about is this. The jet stream, this is a great website out of State University of New York at Albany, and it's showing us that our jet right now in the Pacific is poleward shifted. And that could be a reason why we seem to be unable to get major change in temperature over Alaska to start to drive a different pattern across the U.S. But I'll be watching this carefully to see any big shifts in it. What I do note is this. Over the next, well, let me rephrase that. Over the time period of November 10th to December 10th, we do see that the atmospheric pressure is forecast by the European model to be quite high near the Aleutian Islands and the Gulf of Alaska, and low here. So what I could foresee with this is that northward shift in the polar jet coming into this area, and then kind of diving around this trough, and then exiting here. There's that presence of the southeastern ridge. See the warmer colors. And given all of that, that makes a lot of sense when you see the model's forecast for precipitation, right? So it's kind of coming around. There's the ridge and the dryness, okay, coming into the west, turning over the ridge. So if there's a place that's drier, it could be the southeast. I'm saying drier, not dry, because the atmosphere has to pull the flow into the west and then turn it through here. You're going to get southwest flow. This is why this mid-November to mid-December timeframe looks wet in this area. That's an area that we've been incredibly dry. My big question is, how far up the East Coast does the precipitation try to make it? And can we get moisture into the southeast? And are we really this dry in the mountains? I mean, if you got flow coming in, why would we have lower precip in the mountains? That's an interesting model artifact I'm going to have to look into. But this is way more active than September and October have been. And it's not just the ECMWF that sees it. This is the week 3, week 4 outlook from the CFSV2. You can see the same scenarios I just described. If there's risk of dryness, it's here, but quite wet across these other broad areas, northwest, parts of the west, and then getting into the Midwest, central United States, mid-south area. Okay, so that's another piece of the subseasonal puzzle. Another part I'm trying to watch is the MJO movement, and this could be critical for all of winter because the MJO is not staying in one spot. It's not collapsing. It came way out phase 4, 5, 6. It's moving through 7, 8, and 1. We talked about that a lot on Monday. Are we going to get an MJO that likes to do this all winter? Because if it is, if the MJO signal isn't locked into place because of La Niña, then that's going to give us an active winter, the type that doesn't get stuck, but we just see routine in the weather systems. So I'll be watching this as a major component of that and explaining a bit more to you with time. But I do want to give you the latest forecast from the CFSV2, just given that I want to provide some long-range content. And this is the only model that's been updated lately. And this is kind of a 6-panel outlook for a 3-month sighting window. So November, December, January, February, and so on. Not a whole lot of change in its temperature forecast, but a couple of things I noticed in the precip forecast. While the Northwest and Midwest and Mid-South and Ohio Valley remained wet through winter, it did bring drier conditions into Texas and up into parts of the Southwest, including more of California. And it is what it is. January, February, March. It's a single model run. Well, forgive me. It's a single model. We're using multiple runs from it to average. But that was an interesting trend that I think we're going to have to pay attention to. And that's why monitoring the position of the Pacific High is going to be front of mind for me. If we move it west, get it way over here by Hawaii, or shove it south, this will go wet. And that's what we'll have to see week to week. Okay, from there, let's talk a bit of global weather in the near term and finish up with South America. I just want to give you a 10-day outlook from the European. And of course, a lot of Europe is drier right now, wetter in this part of Western Russia. We can see, though, that big sections, according to the European model, are wet in parts of South America. And a reminder, in the last 30 days, we've kind of filled in a lot of this area, which was very dry in September through the front half of October. But because the second half of October has been so wet, we've now seen precipitation amounts really come up here. This is what the next 7 days looks like according to the European model. We're still very dry in southern Brazil. And like I mentioned on Monday, not a major issue. This was an area that was extremely wet leading up to this time period. I see better rains in Buenos Aires over toward Cordoba, but we're a bit drier in the headwaters of the Paraná River. Okay, but week 2, there's no shift at all in the models. They continue to show a broader area, a corridor that's showing up wetter with time. So where does this go? I think the MJO movement will be critical for this. And I'm just going to tell you something. As we get into the full rainy season for South America, if the MJO lives over in phase 4, 5, if, for example, it doesn't just keep going around, but instead stalls out over here, that is where we start to have the discussions about being dry in Brazil. The wetter side of this diagram for Brazil is phases 7, 8, 1, and 2. Okay, the drier side is phase 4 and 5. So just remember that quick rule of thumb. We're way over here right now, and I just showed you the forecast. It's very much linking up with the MJO. Because the MJO is expected to continue moving all the long-range models are just like, keep the better chances for wetter conditions here, drier on the northeast side, and possibly into central Argentina. And we've shown you that many times. This is also a quite common precipitation pattern when you have a La Niña. And our La Niña continues to be a presence, and it's developing. Some indications of some brief strengthening are seen in the Southern Oscillation Index, but that would tell me what the trade winds look like over here from Tahiti to Darwin. But we've lately seen a lot of colder water upwelling right here in this Niña region 3 to close to Niña region 1+2. So given all of that, can I do one more thing for you before we wrap this up? I'm just going to show you two maps. They're global. And we're going to look at November to December. And I'm going to show you a correlation map with precipitation rate against ENSO, or El Nino in the Southern Oscillation. So the blues represent a negative correlation. This would be positive. So this would be wetter during a La Niña, and this would be drier during a La Niña. And you note that much of northern Brazil tends to do well. The Amazon tends to do wetter. But southern Brazil into Argentina tends to be drier. And also the southern tier of the United States tends to be drier. Australia wetter, just as an example. And then this is a map, similar color scheme, but now we're not looking at correlation, we're looking at anomalies for when you look at all of the weak La Niña years. I did an analysis with this last week, so we're kind of looking at the same thing. And some similarities. Drier in the south and southeast United States, wetter northwest, wetter California. See that? So this is interesting, noticing this for California, given that the forecast was drier that I just showed you from the CFSV2. Much of the rest of the Midwest, Plains, Canadian Prairie, Great Lakes, even the Northeast tends to be wetter too. Take a look at South America. Wetter from the east coast into Mato Grosso do Sul. Drier along the Bolivian Ridge. Dry in southern Brazil. So we just have to weigh the La Niña against all of the subseasonal factors, knowing that if La Niña at times takes over, this will be a common precipitation pattern. So I covered a lot today. I appreciate you giving me some time to do it. Apologize for not having a video for you tomorrow, but we'll get back to normal cadence soon. And with that, I'll wrap it up. I hope you all have a good one and enjoyed at least my story about the potash mine. Have a good one. Thanks.